So, hi everyone, this video is about my packet tracer activity in chapter 9 that is entitled as the exploration of the TCP and UDP communication. So, watch this. This activity is from chapter 9. This is a packet tracer that is entitled as TCP and UDP communication. So, the objectives. Generate network traffic in simulation mode. Part 2 is examine the functionality of the TCP and UDP protocols. So, the background is this simulation activity is intended to provide a foundation for understanding the TCP and UDP in detail. Simulation mode provides the ability to view the functionality of the different protocols. As data moves through the network, it is broken down into smaller pieces and identified in some fashion so that the pieces can be put back together. Each of these pieces is assigned a specific name, which is the protocol data unit or the PDU, and associated with a specific layer. So, packet tracer simulation mode enables the user to view each of the protocols and the associated PDU. The steps outlined below led the user through the process of requesting services using various applications available on a client PC. So, and this activity provides an opportunity to explore the functionality of the TCP and UDP protocols, multiplexing, and the function of port numbers in determining which local application requested the data or is sending the data. So the part 1 is generate network traffic in simulation mode. Step 1. Generate traffic to populate address resolution protocol or the ARP tables. Perform the following tasks to reduce the amount of network traffic viewed in the simulation. So first, click multi-server and then click the desktop and then command prompt. And now enter the ping 192.168.1.255 and then enter. So this will take a few cents device or responsive multi-server, so but it has a reply here. Then close the multi-server. So first we will wait until it is done replying. So we will close it now. And step 2, generate web HTTP traffic. Switch to simulation mode. So this is, we are here in real time mode, so we will switch to simulation mode. And now we are in simulation mode. Next is click HTTP client. So the HTTP client is here on the topology. So let's click it. And then click the desktop tab. So this, we're here on desktop tab, and then we will go on web browser, and then in the URL field enter 192.168.1.254 and then click go. So envelopes videos will appear in the simulation window. So this is, it has an um, show in the simulation window. Then minimize but do not close the HTTP client configuration window. So let's minimize. So as you can see, the topology has a envelope in the HTTP client. Then step 3 is generate FTP traffic. So we're here in FTP client, and then desktop tab and command prompt. Now we will enter the FTP and then 192.168.1.254. then enter. So the display is trying to connect 192.168.1.254, and PDUs will appear in the simulation window. So let's see. So it has this is the FTP client that is shown in the simulation window. Next, we will minimize it, and it has also an envelope here. The next, generate DNS traffic. So DNS client, and then we will go here on desktop, and then we will choose command prompt, and the PDUs will appear in the simulation window. So we're here on enter the NS lookup multi-server.ptu command. So we will type here the NS lookup space multi-server .pt.ptu, then so it will appear on the simulation window. As you can see, it is here. And then we will minimize also this window. The next is generate email traffic. So click email, and then we will go on desktop and then email tool. So we will find here the email tool. So this is the email tool, and then in compose, click compose, and then enter the following information. So to user at multi server .pt.pt, and then the subject, so personal the subject line, so we will write here connect, and then email body, personalize the email, so we will write here connect also, and then click send. So we'll click here send, then we will minimize it. So it is also displayed in the simulation window, and it has an envelope here in the topology. The next is verify that the traffic is generated and ready for simulation. So every client computer should have PDUs listed in the simulation panel. So as you can see, it has all simulation. It has a PDU listed in the simulation panel. So then part 2, examine functionality of the TCP and UDP protocol. So examine multiplexing as all of the traffic process the network. So you will now use the capture forward button and the back button in the simulation panel. So we're here on um, simulation panel, and then we will click the capture forward once, and as you can see, the envelopes are transferring and sending. So next, click capture forward again. Some of the PDUs disappear, and as you can see, some of the PDUs disappear, and it sends the envelope in the multi-server. So what do you think happened to them? So they are stored in the switch. Next is click capture forward 6 times. So 1, 2, 3, 4, 5, 6. So we already clicked it 6 times, and all clients should have received a reply. Note that only one PDU can cross a wire in each direction at any given time. What is this called? So it is called as the multiplexing. Next, a variety of PDUs appears in the event list in the upper right pane of the simulation window. Why are they so many different colors? So it has different colors because it represents that it has a different protocols. The next is, so click back 8 times. This should reset the simulation. But do not click reset simulation. So 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So it resets. The next is step 2. Examine HTTP traffic as the clients communicate with the server. Filter the traffic that is currently displayed to display only HTTP and TCP PDUs. Filter the traffic that is currently displayed. So click Edit Filters and toggle the Show All None checkbox. So I click it and then so select HTTP and TCP. Click anywhere outside of the edit. So we will click the HTTP and the TCP. And then next is select HTTP and TCP. Click anywhere outside of the edit filters box to hide it. The visible events should now display only HTTP and TCP PDU. So click capture forward, hold your mouse above HPDU until you find one that originates from this HTTP client. Click the PDU envelope to open it. So it don't have don't have TCP, HTTP and the TCP. Then so we will click the PDU capture. Click the inbound PDU details tab and scroll down. So we click it and then click the inbound PDU details. So I click it and scroll down to the last section. What is the level? And last section is the TCP. So the last section labeled is the TCP, and are these communications considered to be reliable? So yes, it is considered to be a reliable. The next is record the SRC port, the port sequence num and ACK num values. So to record it. Okay. The next is what is written in the field to the left of the window field. The next, close the PDU and click capture forward until the PDU returns to the HTTP client checkmark. So it go back in HTTP client and then click it. And after we click, we go on inbound PDU details. There is a second PDU of a different color, which is CTP. Wait. Click the PDU and select inbound PDU. How are the port and sequence numbers different than before? So The source port is now 80 and the destination port now is 1025. The sequence number is 0, the acknowledgement number is 1. Then the source and the destination ports are reversed and the acknowledgement number is 1 and the SYN has changed to SYN plus ACK. Then we will go on to there is a second PDU of a different color which HTTP client has prepared to send to multi-server. This is the beginning of the HTTP communication. Click the second PDU envelope and select outbound. So this is. And we will click the outbound PDU details. And then what information is now listed in the TCP section? How are the port and sequence numbers different from the previous two PDUs? So the 1025 now is the source port and the destination port is 80. So the sequence number is 1, the acknowledgement number is 1 also. And the source and the destination ports are reversed and both sequence and the acknowledgement numbers are 1. Then we will close it and click back until the simulation is reset. So we'll go back in simulation window and click back. So until it is reset. So it's now reset. And then step 3, examine FTP traffic as the clients communicate with the server. In the simulation panel, change edit filters to display only FTP and TCP. So FTP and the TCP. Click capture forward and then hold your cursor above each PDU until you find one that originates from FTP clients. So and it is from the switch. And now is so we will go on inbound. So we will record it. The source port is 1025, the destination port is 25, and the sequence number and the acknowledgement number is 0. Next, close the PDU and click capture forward until the PDU returns to the FTP client with a check mark. So capture forward. Let's see if it has a check mark on it. The FTP client. So it has a check on the FTP client as you can see here in the topology. The next is click the outbound PDU details tab. Click the outbound PDU details at click the PDU envelope and select inbound. And then how are the port and sequence numbers different than before? So the source port now is 21, the destination port is 1025, and then the sequence number is 0 and the acknowledgement number is 1. So next, click the outbound PDU details. How are the port and sequence numbers different from the previous two results? So the TCP now is 1025 and the destination port is 21. The sequence number and the acknowledgement number are 1. Next, close the PDU and click capture forward until a second PDU returns to the FTP client. The PDU is a different color. So let's wait. when it come back to the FTP client. So it is different color. So open the PDU and select inbound. Scroll down past the TCP section. What is the message from the server? So message, welcome to PTFTP server. So we will click back until the simulation is reset. They will reset it. So it's now reset. And then step 4, examine DNS traffic as the clients communicate with the server. In the simulation panel, change edit filters to display only DNS and UDP. Edit filters, so DNS and the UDP. So UDP and the DNS. Where is the DNS? So DNS and the UDP. And then, so we will click it, the envelope here, and we will open the, so what is the section labeled? DNS query. So are these communications considered to be reliable? So this communication is not considered to be reliable. Record the SRC port and this port of this, and then close. Click the PD envelope and select inbound PD details. How are the port and sequence numbers different than before? Then close PDU and until PD returns to the DNS. We will wait it. Then it has a check, so we will check, we will pick it, and then inbound details, and how are the port and sequence numbers different than before, and what is the last section of the PDU call? So the last PDU section is the DNS answer. So we will click back the simulation reset. So it is now reset. And then we are proceeding on the step 5. Examine email traffic as the clients communicate with the server. In the simulation panel, change edit filters to display only the POP3, SMTP, and the TCP. So edit layers, TCP, the POP3, and the SMTP. And then click capture forward. So click capture forward, hold your cursor above each PDU until you find one that originates from email client. So what is from the email client? So it is. And then go on to the inbound PDU details tab and scroll down to the last section. So what the transport layer protocol does email traffic use? So it is the TCP. And are these communications considered to be reliable? Yes, it is considered to be reliable. And record the SRC port. So what is written in the field to the left of the window field? It is the 1025, the 80, the 00 of the sequence number and acknowledgement number. The next is close the PDU and click capture forward until the PDU returns to the email client. So let's wait until it go back to the email client. So now it is now in the email client. So click the video envelope and select inbound video details. So with inbound video details. How are the port and sequence numbers different than before? So now the TCP source port is the 25 and the destination port is 1025. And the sequence number remains 0 and the acknowledgement number become 1. And then we will click on the outbound video details. So how are the port and sequence numbers different from the previous two results? So the source port and the destination port reverse and the sequence number become 1, same as the acknowledgement number is 1. The next is, there is a second PDU of a different color that HTTP client has prepared to send to multi-server. This is the beginning of the email communication. So click the second PDU envelope and select outbound. So this is the color violet and we will click on outbound PDU details. And then, how are the port and sequence numbers different from the previous two PDUs here? So the source port is 1025 and the destination port is 25, but the sequence number and acknowledgement number remains 1. The next is, what email protocol is associated with TCP port 25? What protocol is associated with TCP port 110? So it is the SMTP and the POP3. So SMTP for the TCP port 25 and POP3 and TCP port 110. So we will close it and click back until the simulation is reset. So it is now reset. And then step 6, examine the use of port numbers from the server. To see TCP active sessions, perform the following steps in quick session. Switch back to real-time mode. So we will switch to real-time mode. And now we're in real-time mode. As you can see, the simulation window is closed. Then click multi-server and then click the desktop tab and then command prompt. Enter the netstat command. So netstat. Then enter. So what protocols are listed in the left column? So the listed is the TCP. So TCP. Next is, what port numbers are being used by the server? So the port is this 21 port 20. The next is, what states are the sessions in? So the sessions in are the possibly states include the active connections and that is established. State connection here is established. And then repeat the netstat command several times until you see only one session is still established. For which service is this connection still open? So in this first try of netstat command, it only displays one protocol, which is TCP, and it is established. Why doesn't this session close like the other two? So the server is waiting for a password from the client. And then that's all, and thank you for watching this. So that's all, guys, and thank you for watching this video. So I hope you understand and you learn from this. So I'm Kisha, Lyka Villanueva of IT 2105.